Okay guys, from today I talked about showing you precipitate reactions, and I'm just going to first start off with some tap water, clear and colorless, and I'm going to add some silver nitrate to the tap water, a few drops here, and pretty sure you're going to be able to see that on the video. But we're starting to get a white cloudy substance inside of that beaker as the sodium or as the silver nitrate dissolves. And that white cloudy material is a solid particles which are known as a precipitate. And that will, if I leave this overnight, tomorrow morning we'll have a nice solid white layer on the bottom. I'm just going to bring that in close. I don't know whether you can see that, if that's better. Okay, so now I'm going to model for you about this reaction between the water and the silver nitrate. Okay, so just to add some things here, the water that I had in the beaker actually has, because it comes from our water treatment, it actually has chlorine added to it, but I want to just model a few things for you right now about chlorine. Chlorine, when it is added to drinking water, will dissociate, and for simplicity, there's different types of ions that are formed with chlorine involved with it, but I'm just going to model it with just a chlorine ion. It's not really the case, but it's a chlorine ion that we're concerned about. So we've got some chlorine ions that are found dissolved in our water, and of course that helps in making our drinking water safe. And now I'm going to add the silver nitrate to our solution. And there's a few things I want to talk to you about when we're looking at this type of reaction and explaining why that precipitate would form. It really comes down to about attractive forces. And the attractive forces, you have to determine if there are attractive forces that can occur between ions, and then you have to determine if there's attractive forces that can occur between water. So if the attractive forces are such that the atoms or molecules are more attracted to water, then we know dissolving is going to happen, and we would class it as being soluble. If the attractive forces are between ions, then we're going to have a situation where they're not soluble, they'll come out of solution, and we would describe that as being an insoluble molecule. Forms a white, in this case a white cloudy, it's not always white, and it will come out of solution as a precipitate, known as a precipitate. Okay, so here we go. Let's look at to see what's going to happen when I add my silver nitrate. The fact is, a precipitate is formed. So we know there's something that's insoluble. There was something that was strongly attracted to one another that it would no longer allow it to dissolve. And the reaction goes like this. Between silver nitrate, the attraction is greater between for the water molecules than it is between the silver nitrate itself. So that could be our first step in this reaction. So let's add some more silver nitrate. And we can work at this one over here. And we can have that water in the dissolving process is going to be able to fit in between that silver nitrate. There's a greater attraction of silver to the water than there is to the nitrate. If not, water could not be able to get through. Recall, silver nitrate is our solute, and solutes must be able to separate in order for dissolving to happen. So now we have a situation set up here where we have silver nitrate has dissolved, and we get this white precipitate that happens. Well, we've got a strong attraction between silver and chlorine. And in fact, the strong attraction between silver and chlorine is greater than the attraction to water. Therefore, these ions combine, and this molecule is insoluble. So let's look at another situation. We have dissolving that's happened here. This silver nitrate is strongly, or I should say more, the chlorine is strongly attracted to that silver. They bond together, and we have another insoluble situation here. And as we add more particles, I'll add these for you. You add more silver nitrate. We're going to first dissolve them, and then we're going to have that strong attraction of that chlorine to that silver, making another insoluble particle. And those particles over time are going to settle. This is our precipitate we're making. Are going to settle to the bottom of our beaker and form a solid insoluble substance known as a precipitate. Okay guys, let's look at another situation. I'm going to show two different things here. I'm going to show, you're very familiar with sodium carbonate. So this model, this representation up here is of a solid sodium carbonate. Okay, and over here I have a liquid magnesium chloride. So I've already dissolved this aqueous solution here, and you can see that the attraction between the magnesium and chloride is less than the attraction between the magnesium and the water. So water was able to dissolve that. The solutes could separate. Our dissolving principle, we can't ever forget that. So what I'm first going to do is I'm going to show you dissolving. It's always good for us to see it again. So I'm going to take my sodium carbonate. I'm going to put my powder, this is me, putting my powder into my water. And I am going to show you dissolving. This does dissolve, so we know that the attractions between the carbonate and the sodium is not as strong as the attraction between the water and the ions. So water is going to be able to get in between that sodium carbonate and dissolve it. So there we have an example of dissolving. Let's take some more powder and dissolve that in here. Water getting in between, and we have dissolved our sodium carbonate. I'll do another one. Okay. Get in between and dissolve that sodium carbonate. Okay, so now we have a solution of sodium carbonate. I'm not going to show you this because we're actually going to do it on your experiment on Monday. And so now let's add into this because we want to see, what's your prediction? Do you think a precipitate is going to form? And we're going to get to a point where you're going to need another piece of information being able to solve this before you actually do your experiment. So now I'm going to add and pour my magnesium chloride solution into the test tube. So we're going to try and do this. Okay, there's my magnesium chloride coming in. Okay, and I'm going to go to the other side here. I'm going to show you, I'm going to take one of these magnesium chlorides, and I'm going to just take it over to here so I can show you on this side. Okay, it has dissolved. Okay, the fact is that when these two substances come together, we are going to form a precipitate. So let's try and guess what that precipitate would be just from your knowledge. Okay, we got two ions. We got a carbonate, or we got actually four ions in here. We got a chloride ion, we got a magnesium ion, we got a carbonate ion, and we got a sodium ion. Okay. So sodium chloride, is that going to form a precipitate? I think we recognize that sodium chloride is soluble in water. That's our common table salt. So our only other alternative is that the magnesium and the carbonate are going to be very strongly attracted to one another, and they are, water is not going to be able to fit in between them. This strong attraction makes that molecule, or the moles of that molecule, insoluble. Okay? So magnesium carbonate is insoluble. So we get quite a few going on here. Let's add some more magnesium chloride to this side. Going through our reactions, Looking at sodium chloride is soluble. Water is going to be able to stay in between them. Magnesium and carbonate very strongly attracted to one another. They're going to attract. Strong attraction. Water can't get in between them. This is an insoluble molecule, and that will eventually settle to the ground. We could see it as a white precipitate during the reaction. Let's take this guy and settle this to the ground. Okay, and let's just do one more. I'll bring this guy in, orient my solution, bring it down into here. Okay. So this magnesium and this carbonate, strongly attracted to one another. This becomes insoluble, settles to the ground. You can have a solid white substance the next day. So it all depends. Sometimes you'll get it right away, depending on the solubility. So now's the thing. How do you begin predicting the precipitate that will form? And if you look in your notes right now, and you go to page 372, you're going to see something like this. Okay? And what that is known as a solubility table. And this solubility table you can start predicting what's going to be soluble or what's going to be insoluble when you combine different aqueous solutions together. So this is known. You need a solubility table. This guy will probably be showing up on your exam. Good thing. Or I'm going to have to make our fourth periodic table, and I'll put it on there. So the black circles, or sorry, let's start with the white. White circles, all these guys over here dissolve. Now you're looking at your table on your in your textbook. Please don't even try to read that. It's too difficult. So get your textbook open. Check that out. You see all those white circles mean that they dissolve, and the black circles mean that they do not. Okay? They do not dissolve. Gray circles are kind of, sort of, a little bit. You're going to see a little bit of cloud formation, but not a really good precipitate, nice settle to the bottom that you can see with some of these other guys. So let's just, out of curiosity, looking at your book, we can go now and look for things like, let's start first with, remember I said sodium chloride is, the attraction is not great enough that water can't fit in between them. And so I'm going to start on the left here, and I'm going to look for my sodium, and I see sodium right there. And look at this. Every time sodium combined with any of these, sodium combined with a nitrate, sodium combined with acetate, sodium combined with halides, which are right there. There's your chlorine right there. They're all soluble, 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 soluble. Easy peasy. Now let's check out our magnesium carbonate. So going along this left side here, I'm going to look for magnesium. There's magnesium. And I see if there's a nitrate, it's going to be soluble. If it's in a solution where there's an acetate, water still, what does this mean? Water's going to be able to still fit between them. The attraction is not great enough for them to form that solid substance. It keeps going until, boom, I hit here with a hydroxide. So magnesium hydroxide is insoluble. And then I go to the next one, magnesium sulfate. Magnesium oxide, there it is, magnesium carbonate, black circle, it's insoluble. Yes, we see this, and this is how we model this.